Happy morning, students. Today we will see what is Frank's Starling law of heart. Okay, so what is this last stage? This last stage that the force of contraction of the heart is directly proportional to the initial length of the muscle fiber within physiological limits. So this can be explained by an example. See, take a rubber band. So what it says is the force of contraction is proportional to the initial length. So you see, if this is the initial length, this will be the force of contraction. If the initial length is more, the force of contraction will be more. If the initial length is very high, the force of contraction will be very high. So this explains the length and tension relationship. So more the fiber is stretched, more will be the force of contraction. So this length tension relationships were given by the Frank-Starling law. In heart muscle, the initial length is governed by the end diastolic volume, how much the ventricle is filled with the blood. So this end diastolic filling or the end diastolic volume will stretch the length of the fiber, and this is in turn going to increase the force of contraction, and thereby it is going to increase the stroke volume. So end diastolic volume, when it increases, stroke volume will increase. So this law explains the relationship between the length and the tension, and it also tells about the effect of preload, that is the end diastolic volume on the stroke volume.